Hello and welcome to part 2 of our lecture video series for Monday, April 10th, where we discuss the concept of a limiting reactant in our stoichiometric analysis of what's going on in chemical reactions. So before we get into the actual chemistry, even though arguably baking is inherently chemistry, let's attack this concept of a limiting reactant by thinking back to our baking analogy. So, for example, let's suppose that I am stress baking. So I'm at my dad's house and I'm reading through all of his stuff in his pantry, and I'm trying to maximize the amount of cookies I make. So I'm looking at this question here, which says, which ingredient will limit my maximum amount of cookies that I can make? So I have my recipe, right? This tells me the proportion of each ingredient that's needed in order for me to make good cookies. And I don't care about the fact that this recipe tells me that I can only make 12 cookies from this. I want to try to figure out my limit, like my maximum amount of cookies I can make. So let's say that I go rifling through my dad's pantry and I see that, okay, he's got a big old bag of flour and a giant bag of white sugar. He's also got this brand new unopened bag of brown sugar, huge box of salt, whole bag of chocolate chip cookies, this giant slab of butter. This one that is 4 sticks put together, and a big old box of baking soda, and then a whole set of dozen eggs. So I'm feeling good so far about my baking process. I've got what seems like enough ingredients that I can make a whole bunch of cookies. And then I go digging through the spice cabinet, and in the very, very back, I see a bottle of vanilla extract that is probably as old as I am. It looks like it hasn't been opened or used since since the 90s, maybe even the early 2000s. And this is where my intuition kicks in. Because if we look at my recipe, which says, yeah, you're going to need a whole cup of butter, definitely looks like I have that, and a cup of white sugar and a cup of brown sugar, definitely have that in multiples, and 2 eggs, I've definitely got multiples of those, and etc., etc., etc. If I look at the requirement for vanilla extract, and remember, I like to overload on my extract, we could see here that this particular amount of vanilla extract seems like this is going to be the ingredient that runs out first in my recipe. So the maximum amount of cookies that I can make is going to be dictated or determined or dependent on the quantity of my ingredients that I have the least amount of. And we have a name for this in chemistry. We call this the limiting reactant. So my intuition here would be that the vanilla extract is what's going to be the limit on how many cookies that I can make. It is going to run out first. So let's define what a limiting reactant is. So define. Limiting reactant. This is the reactant that reacted in its correct stoichiometric proportion, meaning it just follows the ratios of the balanced chemical equation. It's following the recipe. So it's the reactant, then reacted according to the chemical equation or the recipe, runs out first. And what is the importance of this running out first? Well, if I run out of vanilla, can I make any more cookies? No, I can't. I mean, I guess I could, but they wouldn't be good, right? I couldn't make any cookies based on this particular recipe, which says I need vanilla, right? So in chemistry, the limiting reactant is the reactant that when it undergoes reaction in these proportions as required by the chemical reaction is the thing that runs out first. And once it runs out, the reaction stops. Just like when your car runs out of gasoline, it will stop. If I ran out of vanilla extract, I would have to stop making cookies. The reaction stops. And let's think about the kind of end result of what's happening when the reaction stops. So when the reaction stops, ultimately what happens is we stop the production of product. In other words, the quantity of products made is limited. Hence why we call this the limiting reactant. It's what limits the amount of product. So the limiting reactant, Lr, is what runs out first, and it also minimizes or creates or results in the formation of the lesser amount of product. So in my baking example, my vanilla extract would be the limiting reactant because it is what limits my cookies that I can make to being the smallest possible number, right? That's what ran out first, stopped my baking process, and therefore made the fewer amount of cookies. Now, in this baking example, it was a little obvious about which of these reactants would be limiting, right? Like, yes, we were checking the recipe, and even though the vanilla was needed in like pretty small proportion in that recipe in order for the cookies to be made, I had such like a small quantity to begin with that my intuition said the vanilla would run out. But let's look at our baking example again. So what if you go to bake your cookies and you see the following in your pantry? So let's say my dad had not done his like usual insane old man Winco trip and instead all we had was like a couple pats of butter and also this like ancient bottle of almost vanilla extract vapor. So looking at these two ingredients, these two reactants, I wouldn't be able to kind of have an intuition about which of these will run out first. So in order to do that, how would I figure this problem out? Like how would I determine out the max number of cookies that I could make? This is a process of, again, kind of reverse engineering. So I need to think backward. Not think backward. Let's see here. A better way to say this would be I would need to actually think forward or think ahead and compare, like in my mind, the number of theoretical cookies made if the butter runs out first versus if the vanilla extract. So for example, I would need to think if all this butter is consumed, then how many cookies could I make? And yes, I'm drawing this out for you because I'm very cute. So I don't know my number of cookie quantity if I use up my butter. And I don't know the cookie quantity I could make if I were to instead use up my vanilla first. So I would need to kind of consider, in theory, based on how much I had of each, how many cookies could be made. So this requires some calculation. You say, okay, well, according to my recipe, I know that I need this much butter per batch and this much vanilla per batch. So if I have this much butter to start with, and I know how much butter is required, then that will tell me how many cookies I can make. And then do a similar analysis for vanilla, meaning if I know how much vanilla is needed per batch, and I could then use up all the vanilla I have, figure out how many cookies I can make then, and then I would compare. So you would compare these theoretical quantities. So when we compare in chemistry these theoretical quantities, what we are going to be doing is we are actually going to be doing a little bit of math. So we are going to use our stoichiometry calculations to determine the quantity or number or amount of product that each reactant could make if used in full or completely used up or runs out first. So that is what we're going to practice in our next video. So now that we understand kind of the idea of a limiting reactant, let's see if we can't identify a limiting reactant, get some more practice with our stoichiometry. So we're going to look at stoichiometry practice and solution. This is going to be an example that involves kind of everything we've learned about aqueous reactions so far. And then we will get a glimpse into titrations, which is a wet bench analytical technique that utilizes stoichiometry to figure out some unknown concentration of different solutions. So see you in part 3 of our lecture video series from Monday, April 10th.